Chapter 6.1, the system of linear equations into variables. Okay, the system of linear equations is a set of linear equations. So we can use the square bracket like this. Okay, so here let's consider this question. Is a order pair 3 and -4 a solution of the following? Okay, the following is the system of linear equations. Okay, we call this system of linear equations, and this one has two equations, and each equation has two variables. So let's say the first equation is number 1, the second equation number 2. So each equation is a linear equation. So linear equation, so the graph is a straight line. So the graph of the first equation could be, something like this. And the graph of the second equation is a straight line, something like this. And if the order pair, the given order pair is a solution, that means that should be the intersection of these two lines. Then we call this the solution. So solution is the intersection of these two equations, two lines. So if a point lies on one line, then that's the solution for that line, but that is not the solution of the other equations. For example, if you have a point like this, then this point is a solution for the second equation, but this point is not a solution of the first equation. So if an order pair is a solution of a system, then that point should lie on both equations, both lines. Okay, so how do we check if the order pair is a solution? Just plug it in. So plug the points in each equation. So from the first equation, let's plug in 3 and -4. So replace x with 3 and y with -4. So from the first equation, 2 times x is 3 and y is -4. And let's check whether this is equal to 18. Then this is 6, negative plus 12, this is 18, which is equal to 18. So this point is on the graph of the first equation. Okay, let's check the second equation. Okay, x is 3, 4 times y is -4. Let's check whether this is equal to -13. Then this is 3 minus 16, then this -13. This is equal to -13. So yes, the given order pair satisfies the second equation. Also it satisfies the first equation. So actually this point is the solution. So that's the intersection. So in this case, the intersection is 3 and -4. When x is 3, y is -4. So yes, the answer is yes, the order pair is a solution of that equation. So always check, plug in those x and y values for each equation, and if it satisfies both, then that will be the solution, and that solution is the intersection of two graphs. Okay, let's consider the types of system of equations. Okay, sometimes it is possible that two lines cross at one point. Then that means this intersection is the solution. Sometimes two lines may be parallel. So line 1 and line 2 is parallel. Okay, the first one is there's an intersection. The second type is parallel. Okay, if two lines are parallel, then what? Line 1 and line 2 are parallel, then two lines never intersect, never meet each other, so there is no solution. In this case, there is no solution because two lines never intersect. The first case is there is exact one solution. Okay. There's another possible type. So a system of linear equations can be like this. The first equation, the graph of the first equation is this. The second graph, the graph of the second equation is exactly the same as this. Exactly the same. So line 1 and line 2 are the same. That means the intersection is all the numbers in the line. So in this case, there are infinitely many solutions. So there are three types of system of linear equations. One, there's exact solution, one solution. There's no solution, and there are infinitely many solutions. So if there is a solution, then we call that system is consistent. If there's a solution, then the system is consistent. We call this consistent system. And also this system is consistent. If there is no solution, then it's inconsistent. So the system is inconsistent. Also, there's another definition for dependent. If two lines are exactly the same, the third case, then we call it dependent. The system is dependent. Okay, and then the others are independent. So if there's a one solution, then this is called independent. Also, no solution is independent. So based on the type of solutions, we say that the system of equations are consistent or inconsistent, dependent or independent. So keep in mind this type of system of equations. There are three types always: exact solution, no solution, and infinitely many solutions. Example 1. Solve the system of equations. There are two equations, and let's say the first one is equation 1, the second is equation 2. Then as you can see, this second equation, the second equation is y equals something. That means, okay, using the substitution method, the substitution method is this. We will substitute 2x. Substitute 2x because 2x is equal to y. So we will substitute 2x for y in the other equation. So we will replace y in the first equation with this 2x. That's the substitution method. So one of the equation is written as y equals something or x equals something. So in this case, the second equation is y equals something. So substitute that expression for y in the other equation. So what we'll do is we will replace y in the first equation with 2x in the second equation. Then from the first equation, 3x minus 5y is equal to 7. So what we do is we will replace y with 2x. Y will be replaced by 2x because the second equation shows that y equals 2x. And then from this equation, let's find x. 3x minus 10x equals 7. Negative 7x equals 7. So from this, we got the x value, which is x is negative 1. So we found the value of x, which is negative 1. Then using the first equation or second equation, you can find the y value. Okay, in this case, it's better to use the second equation because second equation shows that you can get the y directly from this. So y equals 2x, and we know what the value of x is. So 2 times x is negative 1, then y is negative 2. So that's the y value. So the order pair for x and y is, x value comes first, so negative 1 and negative 2. So this is the solution. So once you graph this, if you graph it, then probably, let's say this is line 1, and this is line 2, okay, line 1, the graph of line 2, then this is the intersection, which is the solution. then the solution is -1 and -2. So this is substitution. So rewrite one of the equations so that the equation will be y equals something or x equals something. And then replace that expression for x or y from the other equation. Okay, let's try example 2. Okay, solve the system of linear equations, and this is a type of inconsistent system. Okay, inconsistent system is what? There's no solution. So no solution means two lines are parallel. So anyhow, let's check how we can identify this is inconsistent system. Okay, so let's say the first one is the equation 1. This is the equation 2. Then from the equation 1, okay, let's use a substitution method. So equation 1, so from this equation, let's make it x equals something. So move 3y to the other side, then x will be 6 minus 3y. And then I will substitute 6x, 6 minus 3y for x from the second equation, because we want to use substitution method. So from the second equation, we will substitute 6 minus 3y for x. So 2 times x will be replaced by 6 minus 3y. And then let's solve this equation for y. So this equation has variable. This equation has variable y. So we can solve for y. Okay, then 6 times 2 is 12 minus 6y plus 6y is equal to -18. And 6y and -6y and 6y cancel out, so we have 12 equals -18. Look at this. The result is we should have y equals something or x equals something, but those variables are gone, and what we have is an equation that is not true. Okay, this equation is not true, right? Not true. So if an equation not true, this means, okay, this is really important. This means the system of equation has no solution. No solution. Very important. So if an equation is not true, then we will conclude that the system has no solution. No solution. No solution means the system is inconsistent. This means two lines are what? Two lines are parallel. Two lines are parallel. Line 1, line 2. Two lines are parallel. Okay. Why is it parallel? Okay, let's check. Okay, the equation 1, from the equation 1 is x plus, okay, let's rewrite the equation so that in slope-intercept form, then the first equation will be 3y is equal to -x plus 6 divided by 3, then -1/3x plus 2. Okay, the first equation. The second equation is 6y is equal to -2x minus 18, then divided by 6, then -1/3 x minus 3. So let me erase this. Minus 3. So look at this. The equation 1 and equation 2 has the same what? Same slope. The slopes are the same, that means what? Two lines are parallel. So slope 1 is equal to slope 2. That means line 1 is parallel. Okay, parallel to line 2. And as you see this, the y-intercepts are different. That means two lines are in a different location. So line 1 line 2, right? They are parallel and located in they're located in different place, so they are parallel, they never meet each other. That means there's no solution. So it's really important when you solve a system of equations and then the result is not true, the result is an equation, but that is not true, false, then you always conclude that there's no solution. What if the equation is true like this? If the equation is true, then how do we conclude it? We conclude that the system is, this case, this means line 1 and line 2 are exactly the same. So there are infinitely many solutions. So keep in mind that the equation is true, then there are infinitely many solutions, which means two lines are exactly the same. And if the equation is false, the result of the equation is false, then there is no solution. Okay. Very important. Example 3, solve the following system of linear equations. Okay, this is an example of dependent system. Okay, if a system is dependent, that means two lines are exactly the same, so there are infinitely many solutions. So let's check how we can find the solution for this. Okay, so let's say the first equation is equation 1, the second equation is equation 2. So let's use the substitution method. So using the substitution method, why don't we try equation 2? So equation 2 has variable y. So let's rewrite the equation. So move y to the right, there will be positive y, and then the left side will be 2x minus 4. What I did is I switched the interchange side. So move 4 to the left and 2x minus 4 and write it on the right side. And the negative 5, move to the right, that is y, so write it, interchange the side. So we can replace, okay, from the equation 2, we got 2x minus 4 for y. So I will replace this 2x minus 4 for y in where? In the first equation. Because we got y from the second equation, then replace y in the first equation with that expression. So from the equation 1, let's replace this y. So 8x minus 4, y is 2x minus 4. And this equation has variable x, so we can solve for x. So 8x minus 8x plus 16 is equal to 16. And when you combine these variable terms, you can cancel out. Then what we have is 16 is equal to 16. Look at this. We should have x equals something or y equals something, but this equation is 16 is equal to 16. Okay, this implies that what? Okay, this equation is true. This means, true means what? Two lines are exactly the same. That means there are infinitely many solutions. Okay, so actually, two lines are exactly the same because we have a equation that is true, so there are infinitely many solutions. So once there are infinitely many solutions, then there are two lines are what? Exactly the same. They are identical. They are identical lines. So if you see this, okay, let's rewrite the equation 1. From the equation 1, okay, let's rewrite this in a slope-intercept form. Then y equals, this is 4y, so y, negative 4y is equal to negative 8x plus 16. Divide each side by negative 4, then 2x minus 4. And from the equation 2, 2x minus y is equal to 4. Then negative y is equal to negative 2x minus plus 4. Divide each side by negative, then it will be 2x minus 4. As you can see, this line 1 and line 2 are exactly the same. So we know that the solutions, there are infinitely many solutions. Then what will be the type of the solutions? So let's say, since there are infinitely many solutions, then you will be composed of x coordinate, y coordinate, x values and y values. Then let's say x value is a real number c. Then what will be the y value? Okay, the y value will be, as is from the second equation, y is 2x minus 4. So if x equals c, then y will be 2c minus 4, because y is from this 2x minus 4. From the second equation, y is 2x minus 4. Replace x with c, then it will be 2c minus 4. So that's the y value. So since there are infinitely many solutions, the type of the solution will be c and 2c minus 4, where c is a real number. Okay. So for example, if c equals 0, then y will be 0 minus 4. If c equals 1, then the y value will be 2 minus 4 is negative 2, and so on. So there are infinitely many solutions. So this is the type of the solution. Okay, now we will use elimination method, which is also called addition method. Okay, let's say there are two equations, equation 1 and equation 2. Okay, when we do an elimination method, we will eliminate the variable x or y, either x or y. So if we have one equation, let's say one equation has, let's say 13x, and the other equation 13x plus something, and the other equation is negative 13x plus something. Then once we add these two, what happens? One is the coefficient of x are the same with different sign. So one is positive 13, the other is negative 13. Then once you add these two equations, then you can cancel out this variable. So cancel out this variable x means eliminate x terms. So once x terms are eliminated, what you have is only the y variable, y terms only. So in this case, let's use the elimination method. So in this case, why don't we eliminate y? Okay, y, variable y. So look at the coefficient of y. The first equation is 5 and the other one is 3. So the LCD, so LCM, the least common multiple, LCM of 5 and negative 3 is equal to what? It's 15, right? 15. So LCD is 15, LCM is 15. So why don't we make the coefficient of y 15? And this will be negative 15. So one is 15, the other one is negative 15. So that when we add these two equations, then the y terms will be 0. Cancel out, we can eliminate the y terms. So in order to make the coefficient of y to be 15, we have to multiply the first equation by what? 3, right? 3. So you can, here, you can multiply the first equation by 3. And then second equation by what? Okay, negative 3 should be 15, so multiply negative 3 by 5. Then the coefficient of y will be 15. So multiply the first equation by 3. I will multiply the first equation by 3, so there will be 9x plus 15y equals 27. And the second equation is, multiply the second equation by 5, so 10x minus 15y is equal to, multiply by 5, so negative 65. Okay, so we just rewrote the first equation and the second equation by multiplying some number. So that's the second. The description in the second part. So the first part is we find the LCM of the coefficient of x or y to eliminate. So we want to eliminate y. So we will find the LCM of these two coefficients, 5 and -3, and the LCM will be 15. And the number 2 is multiply the equation by a number so that the coefficient of y will be 15 and with different sign. So but we have just multiplied equation 1 by 3. So we got 15y, and multiply the second equation by 5. So we got -15y. And then the next step is add these two equations. Add these two equations. Then we got 19x, and the y terms cancel out because one is 15, the other one is -15. So when you add these two, it becomes 0. Add these two, then 38. Okay, so we got 19x equal 38, then divide each side by 19, then 18 over 19 is 2. So we found the x value, which is 2. All right, then since we have the x value, we can find y. So y can be found from equation 1 or 2, it doesn't matter. So let's use equation 1. It doesn't matter, you can use equation 2. So use the equation 1, which is 3x plus 5y equals 9. So from here, from the equation 1, let's replace this x with 2. Then 3 times 2 plus 5y equals 9. 6 plus 5y equals 9. Then 5y is equal to -6 each side. Then y equals 3 over 5. Is my calculation correct? Oh, well, okay, once you, this is -38, sorry, this is -38, so x will be -2. So multiply 3 by -2, then that is -6. So 5y is equal to 9. Okay, let me double check on this one. Okay, so +6 each side, then this will be 15. So y equals 3. So we have the y value. So therefore, the solution is x is -2 and y is 3. So you can write an order pair like this. So that's the solution. Okay, example 4. Okay, this time, let's use the elimination method, and this time let's eliminate the variable x. So let's say this is the equation 1, equation 2. So the coefficients of x is 3 and 2. So we will eliminate x terms. So we can, so the LCD, LCM, the least common multiple of 3 and 2 is 6. So LCM of 3 and 2 is 6. So let's make the coefficient of x to be 6 and the other one is -6. So why don't we multiply the first equation by 2 and then second equation by -3. Okay, then multiply the first equation by 2, then 6x minus 8y equals 20. Second equation by -3, then -6x minus 15y equals +3. Here, so look at this. The coefficient of x in the first equation is 6, and the coefficient of x in the second equation -6. So once we add these two equations, then we can cancel out the x terms. then negative 23y is equal to 23. So from here, y equals negative 1. So we found the y value, y coordinate, y value. So let's find x. Okay, using either equation 1 or equation 2, we can find x. So this time, why don't we use example 2? It doesn't matter, you can use anything. So let's use example, the equation 2. From the equation 2, 2x plus 5y is equal to negative 1. And then 2x plus 5 times negative 1 is equal to negative 1. Y is negative 1. Then 2x minus 5 equals negative 1. 2x is plus 5 each side. Then x equals 2. So the x value is 2. So the solution is x is 2, y is negative 1. So when we write the solution, we can use order pair like this. Okay, example 5. Okay, to solve this system of equations, let's select the variable to eliminate. In this case, let's eliminate x. It doesn't matter, you can eliminate y or x, doesn't matter. So let's eliminate x, then the LCD should be 3. So in this case, okay, we already have the second equation is 3. So why don't we make this, the coefficient of x to be negative 3. So multiply the first equation by negative 3. And the second equation stays the same. So that the first equation will be, multiply the first equation by negative 3. Then negative 3x plus 6y is equal to negative 6. The second equation is unchanged. And then add these two equations. Then we can cancel out x, or even y is cancelled out. Y cancel out, so the left side of the equation is 0, the right side is also 0. Look at this. If the equation, the result is true, then what's our conclusion? Okay, this is what? This is true. That means there are infinitely many solutions. Infinitely many solutions. Okay, infinitely many solutions means two equations, line 1 and line 2, are what? Identical. So this means line 1 is equal to line 2. So actually equation 1 is equal to equation 2. Are they really true? Yes, because if you see the first equation, if you multiply the first equation, then this will be, multiply the first equation by 3, then this will be 3x minus 6y is equal to 6. The second equation is 3x minus 6y is equal to 6. As you compare these two equations, they are what? Same, right? So two equations are same, which means they have the same graph. So the solution is all the points in the line. So there are infinitely many solutions. So since there are infinitely many solutions, then let's consider the type of the solutions. So we can write the solutions in an order pair xy. Then let's say x is any real number c, any value, any real number c, then we can find y. So from equation 1 or 2, let's use equation 1 to find y. Then let x be any real number c. Then from the equation 1, x minus 2y equals c. Okay, we know x is a value, a real number c. So replace x with c. Then let's find y. Then this is negative 2y is equal to negative c plus 1. Then divide each side by negative 2. So 1 over 2 c minus, this is 2. So divide by negative 2, then this will be negative 1. So y can be written as 1 over 2c minus 1. So the solution type will be, there are infinitely many solutions, and that solution will be in this format. Let's say x equals a real number c, then the y value will be 1 over 2c minus 1. So there are infinitely many solutions, and that solution is in this format. Example 6. Okay, two equations are given, and from this equation we will find the value of P, so the equilibrium price. So let's find P. So using this, let's use the substitution method, because two equations are written in terms of P, x equals something, x equals something. So why don't we use the substitution method? So we can put this expression for x in the second equation. Then 100p minus 25 equals 655. Okay, let's collect the p terms. So move minus 150 to the left. Then this will be 250p minus 25 equals 655. I wrote too many fives. Okay, then move 25 to the other side. Okay, 25 each side, plus 25, then 680. Then P is equal to 680 divided by 250. Then use a calculator, then there will be 2 point something. So there will be 2.72. So the equilibrium price is $2.72. Okay, so just use the given equation and then solve for P. We don't have to find X. Example 7. Okay, we will find the rate of a boat and the rate of the current. So boat is going with the water, and then when you come back, the boat is coming against the water. So let's say the speed of the boat, the rate of the boat is b miles per hour, and the rate of the current is c miles per hour. So when you go from location A to B, which is the distance is 18 miles. So if you row your boat with the water for 18 miles, it takes 2 hours. And if you come against the water, then within 2 hours you can go against the water for 10 miles. So when you go with the water, then the total speed will be the sum of your boat speed and the speed of the current. So B plus C. And when you go against the water, against the current, then the total speed will be reduced. So reduced by, the boat speed is reduced by the current speed. So B minus C. So we can use a formula like this. The distance formula. The distance formula is what? Speed times the number of hours, DST. Remember? Okay. Look at this. Write DST in triangle. And from this, the distance is equal to, draw a fraction bar like this. Then distance is equal to S times T. And the speed is equal to, speed is equal to D over T. And T can be written as T is equal to D over S. So we have 3 equations related to the speed. So from this, we can use distance is equal to speed times the number of hours, ST, DST. So let's write an equation when you go with the water and against the water. So if you go downstream, then the downstream, the total distance is 18 miles for 2 hours. So the total distance is equal to, D is equal to ST. So using this formula, when you go downstream, then the distance is 18 miles, the total speed will be the boat speed and the current. How many hours? 2 hours. So this is given. There's another equation when you come, going upstream. Then the total distance you traveled is 10 miles. And the speed will be B minus C. How many hours? For 2 hours. So we have an equation, two equations like this. So if we put them together, then we can solve for the speed of the boat and the speed of the current. So from here, let's divide each equation by 2. Divide each equation by 2 because it's divisible by 2, right? Divisible by 2. So let's say this is equation 1, equation 2. So divide the equation by 2, then 9 is equal to B plus C. Divide the second equation by 2, then 5 is equal to B minus C. Or you can just distribute B plus C and B minus C by 2. Okay, then from this, let's add the equations. So the coefficient of C is 1 and -1. So why don't we get rid of C, eliminate C? Then this will be 14 is equal to B. So 7 equals B. So the boat speed will be 7 miles per hour. That's the rate of the boat. Okay, let's find C. So using the equation, let's use this equation 3. Let's say this is equation 4. Then from the equation 3, let's find C. So B is 7, the minus 7 each side. So the current of the speed of the current is 2 miles per hour.